Greetings everyone, my name is Bhave and I'm going to be talking about my capstone project with Deque Systems. First off, I would like to thank Dr. Gates and Deque Systems for making this collaboration possible. So let's talk about Deque Systems and what they do. Digital accessibility ensures that everyone, regardless of ability, can access and interact with digital content. With over 1 billion people worldwide having some form of disability, the importance of making websites, applications, and digital tools accessible cannot be overstated. However, implementing accessibility is challenging due to complex standards and the high volume of accessibility related queries that organizations must address. Deque Systems is a leading company dedicated to digital accessibility solutions. They offer tools and services that help organizations comply with accessibility standards and improve digital experiences and integrate accessibility into their development processes. One of their key offerings is ACTS, a suite of accessibility testing tools that help detect and resolve accessibility issues efficiently. And before we get into our project and Access Assistant, let's look at the certifications here that we were required to complete before we could continue with the project. As you can see, these are certifications related to accessibility for non-technical roles as well as technical roles. And these were to basically make us learn about accessibility more before we could dive into the project about accessibility. So let's talk about Access Assistant. Access Assistant, developed by DQ Systems, is an AI-driven tool designed to provide quick and accurate answers to accessibility-related queries. It is trained on DQ University's vast knowledge base, which enables it to categorize and address user queries efficiently and offer real-time guidance on accessibility compliance. It can also generate accessible code snippets and provide documentation references. It improves response times and reduces the burden on human experts. And the team that's working on this particular part of the project is myself, Bhave, my teammates Siddharth Mathur, Abhijay Tyagi, and Rahul Shetty. So let's talk about our implementation of the project. So our project focuses on enhancing the current implementation of Access Assistant to improve efficiency, maintain stability, and response accuracy. While the existing system is effective, there are several ways where improvements could be made, which include reducing complexity, improving query handling, and optimizing resource allocation. The previous version of Access Assistant followed a bot-based architecture with three primary bots, the first being chatbot, the second was the concise bot, and the third was the tools bot. The chatbot would provide detailed explanations on accessibility concepts, and the concise bot would deliver succinct to the point answers. And the tools bot would manage queries related to DQ University documentation and other accessibility tools. Uh, it was quite functional, but its architecture presented certain challenges like code duplication, overburdening the tools bot, and a lack of a clear workflow. To address these challenges, the current DQ team is working on adopting an agentic workflow that aligns with industry best practices such as the orchestrator worker platform. And this approach involves specialized AI agents working under a central manager agent, each focusing on a specific area. This is where our students come in to assist with this part of the project. As you can see, this is the current workflow that has been designed by the DQ University team, DQ Systems team. So this is where the input is provided and then goes to the manager agent. The manager agent analyzes the user query and decides which specialized agent is to be called for the next task. So as you can see, these are a list of the specialized agents. First is the DQU expert, which specializes in retrieving information from DQ University. Next is the products agent. Its specialty lies in the DQ products. The next is the developer agent in case uh, the user wants any code. And next is the remediation agent. So there are certain benefits of this type of approach. Uh, so by transitioning to this new approach, what the team achieved was a better task specialization. Each agent is optimized for a specific role, reducing redundancy and improving efficiency. And they also reduce the complexity, which is a clear division of responsibilities that simplifies system design and maintenance. There was an improvement in response time and easier maintenance and scalability. To basically implement the solution, we were first provided with a document with a list of test cases where Paul himself had first analyzed the first five test cases and categorized them based on intent and a few other things. The task for us initially was to manually analyze the test cases and do the same and fill out the document. So there were about a total of 65 test cases. that needed to be classified, and we split this task between the four of us as a team to get a good understanding of how to analyze the intent. Once we got a good understanding, we moved forward from there. So this is an example of one of the test cases. So let's say the user asks the assistant, write an acceptance criteria for an accessible modal dialog according to WCAG 2.2a. So this is how we would categorize, we would classify this particular prompt. Mainly what we're looking for is the intent. As you can see here is the type of response required, which is to generate, and the desired output is an acceptance criteria plus an explanation. So we were initially tasked with carrying out a prompt engineering task. So we engineering a system prompt which could be passed to the GPT API along with the user prompt, and the API would respond basically with an analysis of the prompt from the user. So we approached this task using OpenAI's prompt engineering documentation as well as following the DQ team's instructions as they were well versed with this. So this was the prompt that was previously built by DQ University's team, and we had modified it to uh, look like this. So this is the prompt that we came up with. As you can see, we have a list of guidelines. We also provided examples so it would understand how to better analyze the user's prompt. Let's dive straight into the results. As you can see, here are the results, and so these are the test cases. And for test case 5, for example, what we had classified it manually was to generate and explain, but what the OpenAI API responded was to generate. And based on comparing these two, these are some of the similarity scores that we found. And we set a threshold of 0.8 to either classify these as pass or fail. And as you can see, for the expected output and the generated output, also we have a similar kind of workflow. So in our findings, most of these were classified correctly. We also worked on continuous refinement of this thing, and so it would iteratively enhance the agent responses based on real-world test cases and user feedback. We also implemented a scratch pad using Pydantic, where it would the OpenAI API would also give its reasoning for why it uh, provided an answer like that for each prompt, which made it easier for us to engineer the prompt in the next further iterations. So this is what the current workflow looks like after the student team worked on it. As you can see, first the input is provided to the manager agent, then the OpenAI API is called, and then the specialized agent is picked. And then the output is again provided to the manager agent, where it can synthesize the output and provide it back to the user. So let's talk about next steps and conclude. So moving forward, we aim to enhance the intent analysis to improve query classification accuracy. We also want to integrate the solution seamlessly into broader accessibility workflows. And we want to explore advanced AI techniques, including contextual learning, to further refine the responses. To conclude, our transition to an agentic workflow significantly enhances assistance efficiency, which reduce by reducing redundancy, improving response accuracy, and making the system more maintainable. By addressing the limitations of the current bot-based systems, we are building a more scalable and effective AI-driven accessibility assistant. This initiative aligns with DQ Systems' commitment to innovation in digital accessibility and ultimately improving user experience and promoting inclusivity in digital spaces. Thank you.